A regular hexagonal lamina of sides 25 mm is lying in such a way that one of its sides on HP, while the side opposite is the side on which it rests is on VP. If the lamina makes 60 degrees to HP, draw the projections of the lamina. So here he says it is resting on one of its sides on HP. The side resting on HP is to be perpendicular to VP, and also it says the lamina makes 60 degrees to HP. So that means he has given the surface inclination with respect to HP. So obviously we have to start the problem from the horizontal plane, and so that the two of the sides is perpendicular to VP because it is resting on HP on one of its sides. Then when you look from the front view, we can see all the sides are resting on HP. So obviously it is parallel to HP. So in the top view, we can see that is on HP. We're going to get the true shape. So as we look from the front view, ABC is near to the observer. A dash, B dash, C dash is visible. D, E, F is away from the observer. So D dash, E dash, F dash is on bracket. So it is a case wherein the surface is parallel to HP and perpendicular to VP. So that is the reason why you are getting a line in the top, in the front view. So when you look from the top view, all the sides are resting on all the A, B, C, D, E, F. All the sides are visible. So then it becomes the true shape. So because all the sides are parallel to HP, so you are getting the true length. Now we can see in the 2D analysis also, as we can see that AF and CD both are perpendicular to VP. So that is the reason why you are getting a point here. The side opposite to this will always be side when you are considering a even number polygon. So now as we see from the front view, ABC is near to the observer. So A dash, B dash, C dash is visible, and D, E, F is away from the observer. So D dash, E dash, and F dash is in bracket. So next is one of its sides is resting on one of its sides on HP. So the side which is perpendicular to VP, there are two sides which are perpendicular to VP. One is AF and the other one is CD. So we can rest it on either AF or we can rest it on CD. Now in this case we are resting on CD, so that the entire surface makes an angle of 60 degrees with HP. Obviously that once the surface is inclined to HP, obviously that surface will going to be perpendicular to VP. So that is the reason why you are getting a line in the front view. And we can see the side which is resting on HP has to be perpendicular to VP. So that is the reason why when you look from the front view, you are getting a point in the front view. Similarly, B and E, B dash is visible and E dash is away from the observer, and C dash is visible and D dash is away from the observer. So it becomes invisible. And since the surface is perpendicular to VP, so obviously we are getting a line in the front view. And we can see here one of the sides is resting on HP. The side which is perpendicular to VP, that is AF, is the one which is resting on HP, A dash, F dash. And as the surface makes an angle of 60 degrees with HP and it is perpendicular to VP, so that is the reason why we are getting a line in the front view. And when you look from the top view, we can see A dash, F dash is parallel to HP and perpendicular to VP, and here also C dash, D dash is parallel to HP and perpendicular to VP. So that is the reason why you are getting a point in the front view and here also. And as we see that A dash, F dash is both A dash, F dash and C dash, D dash are both are parallel to HP. So we're getting the true length here, AF and CD. As we see, A dash, B dash and B dash, C dash is inclined to HP. So we're getting apparent length AB and BC. Similarly, D dash, E dash and E dash, F dash are both are inclined to HP. So that is the reason why you are getting the apparent length here. So the next is the side, while the side opposite is the side on which it rests is on VP. So which is the side opposite to the side? The side opposite to the side is CD. So here A dash, F dash is resting on HP and the side opposite to the side is CD, which has to rest on VP. So you rewrite the second position top view by rotating in the counterclockwise direction by an angle of 90 degrees, such that the CD will going to be on the XY line, and then write the front view. And this is how we can see as AF is resting on HP in 3D and CD is resting on VP. When you look from the top view, that projected surface will going to be like this in the top view, and when you look from the front view, the projected surface on the vertical plane will going to look like this in the front view. So this is how you will be able. How do I know that our problem is right? We can see that one of its sides is resting on HP. As the side has to rest on HP, in the front view it will be on XY line. You can see that A dash F dash is on XY line. The side opposite to the side is CD. That CD is on VP. You can see in the top view CD will be on VP, and the surface makes an angle of 60 degree with respect to HP, and this is the hexagon of 25 mm. So this is how you will be able to analyze this problem. Now we will go to write the solution in the sketchbook. So to do that, first we will go to draw an XY line with a thin line, and you mark XY and VP and HP. So first I need to construct the hexagon such that one of the sides has to be perpendicular to VP or perpendicular to XY line in the top view. So first we will go to draw a vertical line. By using the compass, you take a radius of 25. Consider any point on that vertical line drawn. With that as center, draw a circle, a smooth circle, which should be a light circle, such that it will go to cut this vertical line at this point and also at this point. You mark those 2 points as B and E as shown. Then with B as center, taking the radius of 25 by using the compass, cut on the circumference of the circle on the left side and also similarly on the right side. Similarly with E as center, again take a radius of 25 mm with cut a radius on the circumference of the circle on the left side and also on the bottom side of the the right side of the bottom side. So you mark the point as A, and you mark this point as C, you mark this point as D, and you mark this point as F. Then join A to B, B to C, C to D, D to E, E to F, and F to A with a dark line. Now we need to write the front view. Draw a vertical projector from A and F to the XY line. Draw a vertical projector from B and E to the XY line. And draw a vertical projector from C and D to the XY line. And then when you look from the front view, ABC is near to the observer, so A dash, B dash, C dash is visible. And DEF is away from the observer, so D dash, E dash, F dash in bracket. Then join A dash to C dash with a dark line. Then consider any convenient distance from the first position front view and mark the point on the XY line, and you mark this point as A dash and F dash in bracket. By using the protractor with A dash, F dash as center, and with respect to the XY line, you measure an angle of 60 degree with respect to the XY line in the counterclockwise direction, and then draw a line from A dash F dash on that 60 degree line. Then by using the compass, you measure the distance from A dash to C dash of the first position front view with second position A dash F dash, and you cut an arc on that 60 degree line, and you mark that point as C dash and D dash in bracket. Similarly with the A dash center, taking the radius of A dash B dash, again transfer that distance from the A dash F dash point on that 60 degree line, and you mark this point as B dash and A dash in bracket. Then draw a vertical projector from A dash and F dash, and draw a horizontal projector from A and F. Both these 2 points will going to intersect at this point and this point. You mark the point as A, and you mark this point as F. Similarly, draw a vertical projector from B dash and A dash, and draw a horizontal projector from B and also from E. Both these 2 points will going to intersect at this point E and at this point B. Similarly, draw a vertical projector from C dash and D dash, and draw a horizontal projector from C and D. Both these 2 points will going to intersect at these 2 points, and you mark the point as C, and you mark this point as D. Then join A to B, B to C, C to D, D to E, E to F, and F to A with a dark line. So to write the third position top view, as the side opposite to the side is resting on VP, the side opposite to the side which is resting on HP is on VP. That means you have A dash F dash is the one which is going to be rested on XY line in the front view. So obviously it should be resting on HP. And the side opposite to the side is CD, which is perpendicular to VP now in the second position. You have to rewrite that by rotating by an angle of 90 degree in the counterclockwise direction, such that CD will going to be on XY line. So you measure the distance from C to D by using the compass. Consider any point on this XY line. With that as center, cut an arc on this side, and you mark this point as C. You mark this point as D. Then through C and D, you draw a vertical line to the top view. Then you measure, by using the compass, you measure the distance from C to A and D to F, and transfer it from C and also from D respectively to get this point A and F on the previously drawn perpendicular from both C and D. Then you measure the distance from C to this point and also from D to this point. Both these 2 points will going to have the equal distances. So from C, you cut an arc on that vertical line drawn from C, and also from D, the vertical line drawn from that point D. Then join these 2 points and then extend on either side. Then you measure the distance from this point to B, and from this point, you cut it on this side, you will going to get this point B. And similarly, with this as center, cut an arc on this side so that you will going to get this point E. Then you mark the point as A, B, C, D, E, F. And then join A to B, B to C, C to D, D to E, E to F, and F to A with a dark line. Then you draw a vertical projector from A and F and draw a horizontal projector from A dash and F dash. Both these 2 points will going to intersect at this point as A dash and this point as F dash. Then you draw a vertical projector from C and also from D to the front view. Draw a horizontal projector from C dash and D dash. Both these 2 points will intersect at C dash and D dash. Similarly, draw a vertical projector from E and B. Both these 2 points will going to intersect, and the horizontal drawn from these two points will going to intersect at this point B dash and E dash. Then join, mark these points A dash, B dash, C dash, D dash, E dash, and F dash, and join A dash to B dash, B dash to C dash, C dash to D dash to E dash to F dash, and F dash to A dash with a dark line. So this is how you will be able to solve the solution in the sketchbook, and also finally give the dimensions, which is of 60 degree here, and this is of 25 mm. So how do I know that my problem is right? So one of the side has to rest on HP, so then obviously that will be on XY line in the front view. So that means A dash, F dash is resting on front view. The side opposite to the side is C dash, D dash. The side opposite to the side is resting on VP. So that means CD will going to be on XY line. So you mark this point as CD and throw C and C dash, D dash, both A dash, F dash is on XY line in the front view. So that means it is on the HP. And CD, the side opposite to the side which is resting on VP. So CD will be on VP. And the surface makes an angle of 60 degree with respect to HP. And this is a hexagon of 25 mm. So this is how we will be able to solve the problem. And hence, since we have considered all the conditions given in the problem, and hence the problem is